Thank you. All right. Thank you for joining me today. I'm Adrienne Braganza Tacke. I am ex-MongoDB, and that's very important. And today I'd like to talk to you about data modeling for document databases. So, who here has heard tabloid-esque types of sentences like this? Document databases are schemaless. Raise your hand. Okay. Who thinks that's a bad thing, that they're schemaless? Okay, yeah, be confident in your answer. Yeah, yep. Sometimes it can be, right? And sometimes it's not necessarily a bad thing. But when we work with document databases, so like MongoDB or Cosmos DB or DocumentDB, both of which are actually just based on top of MongoDB, we kind of hear these types of tabloid-esque type of sentiments. So we get things like, oh, there's field flexibility for all documents, and that's amazing. Or what data model, right? The whole point of you wanting to use a document database is that you're not restricted by a very rigid schema. You don't know what that could be at the very beginning. When you are used to working with relational databases, very much like how my background was, that's kind of the first thing that you do, right? You very meticulously detail out what your model is going to be, and then you build out the application. Whereas with document databases, most of the time we kind of argue, well, you build the application first, and then you build your data model along with it. But if there's anything that you get from this presentation today, it's that I want you to take away that there is a data model, that while flexibility is great in theory, it is not great in reality. In reality, all of the data that we work with has some kind of structure. That's the whole reason why it's important to us. That's the whole reason why it's meaningful in our applications. Without that structure, without those relationships, all of this large amounts of data is essentially useless to us unless we make sense of it somehow. And so that's what I want to talk to you about today. How to develop a data model for document databases, either how to refine the way that you build a data model or to show you how to actually build one if you've never heard of this before. The goals of this session are to learn how to create that data model in 3 phases, and then we'll apply that methodology to a casino floor analytics application because I'm based from Las Vegas, and I feel that will be a very, very different example for most of you. And then finally, what I think is the most important, but I leave towards the end so that you can think about it after this presentation, is to understand what exactly we're modeling for. So if there's anything you take away from this, it's that it is possible and it is necessary for you to develop a data model if you are using a document database. Don't go along with the tabloids. Don't just say, oh yeah, we'll just throw some stuff in there, throw some fields in there, we'll be great. Because if you do that, it's going to impact your application's performance. Very much like how the data model that you create for a relational database or an application that uses a relational database, it's going to affect your app. So as an example, it's kind of hard to read, but the whole point here is depending on the data model that you use, you can have someone with the raving reviews of the document database that you've used for your application. Amazing performance. We were able to do this many requests per second, so yada, yada, yada. And then with that same exact database, you'll get reviews like this of, oh my gosh, I'm only working with 1,000 records and it is so slow. What's going on? What's wrong? And most likely, the most common culprit of this is they've taken the relational data model, take all that data, threw it into some document database, and then wonder why it's not working. Well, the model is different. You model data differently in different types of databases, so you have to restructure your data accordingly. And so we'll get through the first part. How do you actually build a data model in 3 phases? So there's a methodology here that's quite iterative. You can go through these 3 phases over time, and you may have to go through them over and over again as your data model evolves with your application. So the very, very first thing that you do is you make sense of your workload. Making sense of your workload means gathering everything there is that you could possibly want to know about your data. Through this discovery phase, you're going to find a lot of inputs as to where you can get this kind of data. First and foremost is listing, qualifying, and quantifying all of the operations that are running through your application. What are the queries that are running through your app? What are the ones that are there but are not being used? What are your most important ones? What are the amounts of those? Is it 2 tweets per hour? Is it this many requests per second? If you can get down to those types of granular numbers, the better you are. Not only do you have a good estimate if this is the first time that you're starting out, but as you go through this methodology over time, you have a baseline that you can see where there are different differentiations or deviations from what your normal was like or from where you first started. So taking into account all of these types of operations, the reads, the writes, everything that you have is a very, very good place to start. The next thing that can help you out are production logs and statistics. So if you already have that tooling in place, if you have those kinds of metrics being recorded, these are very, very good places to look for that additional information. Where are your spiky traffic loads? What quarters are you kind of dormant and don't have as much traffic going through? Where are your unexpected traffic spikes happening? Did they occur because of something that was deployed, or was it because of a timely or seasonal type of issue? These are other good things to keep in mind when you kind of lay out that baseline of where your application is today, especially if you're starting out and creating your data model. Next, current and predicted scenarios. So kind of hand in hand with those production logs and statistics, you kind of ask yourself, what is our normal traffic like? What is our normal expected workload? And then you have some predicted scenarios where, let's say, if you are typical examples in e-commerce application and you have some sort of big holiday sale that you have more traffic than you're used to, those are some sort of predicted scenarios that you can estimate and know that you have to either deploy out more resources to help accommodate that, or even scale back once you're done and finished with that. And then finally, it's always good to collaborate with a domain expert. So as developers, as someone who's working in the weeds most of the time, sometimes we kind of forget about the bigger picture. What are the other scenarios that we're forgetting? What are the other things that are part of our application that we may not be privy to because we're so stuck on this feature, or we've been fixing this production fire for the last 2 weeks? As we start to add more people into the conversation, you always get valuable insight that you may not always have if you are very much down in the weeds of your application. So we take all of these inputs, we gather everything there is possibly to know about our data and what it is, how it processes through our application. And that feeds into some very, very important outputs. The outputs you get from this phase are, number one, the operations that are running. Number two, all the different queries that are running in your application. The data sizes that you are working with, both actual and estimated. Indexes that you have, or indices, however you want to say it, and the ones that you're missing, more importantly, and all the assumptions that you have built in so far to your application. Once you have all of these outputs, you're going to be ready for the next phase. And that next phase is to now map out and identify those relationships. So in this phase, there's two things that you do. You first quantify and identify what those relationships are, and then you decide, do you link or do you embed all of the relationships that you find? So who here has seen this type of notation? One-to-one, one-to-many, many-to-many? That's good, I would hope so. So yes, if you come from a relational background, we're pretty familiar with this, right? Crowfoot's notation denoting which entities have one-to-one relationships, one-to-many, many-to-many, and it's the same with the document database. So that part doesn't change. Those types of relationships still occur when you work with data in a document database. One thing that we did find, however, is now that we're aggregating so much more data and capturing way larger amounts, sometimes the one-to-many relationship doesn't accurately capture that type of relationship. So we've actually added a new one called one-to-zillions. And so if you think about time series data, or if you think about anything where you're having thousands of requests per second, that amount of data would probably qualify for a relationship like this. And so you can see with the Crowfoot notation here, that the little difference here is that we've added a couple extra lines there that says there's a lot on the many side. And when we denote this notation, numeral-wise, what we would find here is you would most likely want to add the minimum, which is usually 0 or 1, the likely amount, which is the most important number here, and that's what's your normal expected amount for this particular relationship on the many side, and then the maximum. So that could be in the millions, the billions, the zillions, whatever that is. A good example of this is actually Twitter followers, right? So most people, they will have at least 0 or 1 as a minimum follower. Most people will have around a few hundred. And then for, the celebrities or people who are super famous, they'll have maybe in the hundreds of millions of followers. So we've quantified the relationships, we found what the most important entities are, we've found what relationships relate to those entities, and now we have to decide, which can be a somewhat long process, is do we link or do we embed? How many here is like what's linking and what's embedding? Yeah, that was me too. I'm like, what is that? And good thing is it's very, very self-explanatory, especially if you come from a relational database background, you already know one of them. So linking, what is linking? Let's say we have a sample document here. This is holding a bunch of casinos. And in this particular document, we hold some basic information about the casino. We have an identifier, we have the name of the casino, nicknames of what that casino could be called, the year that it opened, and then right here is where we link owner with some sort of identifier. So linking just means, very much like a foreign key relationship, we get some additional information that may be stored. In this case, we're storing it in a different document and of course a different collection, which that would be akin to a table. So here, for owner, we would identify that by the identifier 3 here, and that information holds the owner information. So that is linking. Linking is very, very similar to foreign key relationships. We store that data somewhere else and we link to it in the parent document. Embedding, on the other hand, is just taking the most important information or the information that we usually query together, and we take it and embed it into the parent document. So here we find that, let's say when we were querying for casinos, we find that we're always looking for the name of the owner, the headquarters, and the year that it was founded. It would be a good start to kind of take that information and put it into the parent document. And that's embedding. So these are very generalized guidelines as to what you want to do, whether to link or whether to embed, depending on the type of relationship. This is not a framework where you're like, is it a one-to-one relationship? Okay, we're going to link or embed. It's not like that. These are general guidelines. But for the most part, we want to encourage embedding in the document because that goes for a more simple data model. And embedding most things is probably what you'll need. So as you'll see here, for one-to-one, one-to-many, and even many-to-many relationships, if you do embed information in your parent document, you will get a single read, because if you do it the way that it is intended, that single read will encompass all the information that you are accessing via the query you have. So that's one of the tenets of document databases, is any data that is accessed together should be stored together. And so that really encourages embedding for most things. If you are getting into a more complicated data model, or you have a lot of information, or you are working with 1 to zillions, then linking in the parent document is probably better, especially if you're getting to that zillions range on the many side. Linking is going to be preferred, because if you embed all of that information in that many documents, that's also not the greatest thing for your data model. So of course, with linking, you're going to get a lot of smaller reads, but you're going to have many reads. And sometimes that's not always bad. Sometimes your application needs that. And sometimes the sacrifice that you make for having an additional read is what your app needs, rather than having a very, very fast read. So we've taken all of the information that is part of our application. We take all of those inputs and the data about our workload. We've now mapped out what the different entities are. We've mapped out what the relationships exist between all of these. And actually, at the end of this phase, you pretty much have a data model that you can work with. The one thing that we encourage is that for phase 3, which is applying design patterns, you most likely don't need to get into that unless you absolutely need it. So when you are done with phase 2, we only encourage, if you are starting to see performance problems, Or if you find that you have a performance threshold that you are not meeting, then you kind of go into step 3 or phase 3, because applying design patterns prematurely is very much like premature optimization. You come out with a data model that's a little bit harder to understand, a little bit harder to iterate on, and a little bit harder to adapt. So only when you need it do you go into the design pattern phase. And so with that, what are design patterns? Well, it is a reusable structure to a commonly recurring problem. So if you've ever read design patterns for computer science in general, right, the Gang of Four, or any other type of acronyms or things like that, it's the same type of concept. It's something that you want to reuse when you're solving some particular problem. And in this case, for data modeling, these are models that you can adapt to your data model depending on the data that you have that fit very, very common use cases that we've seen. So what design patterns are available? And I'm going to come here because it might be difficult to see. Remove, just in case. Yep. So we have very many design patterns. We're going to go through a few that we'll actually use in our example. And here we'll start with the polymorphic pattern. So the polymorphic pattern, who here has heard of the term polymorphic? Okay, so then you will understand what polymorphic means. In the case of these design patterns, all this means is that there are a variety of documents that can exist within the same collection. So we take our example here. We have, let's say, a sports betting application, and we're having the list of all the different athletes that are here. So we have the late, great Kobe Bryant right here. And we have some information about him specifically because he played basketball, right? So for basketball, we keep the number of NBA championships that he's been a part of, if he's in the Hall of Fame, etc. Now for Serena, we still keep the sport, the athlete name, and the career earnings. But for Serena, she plays tennis. So a lot of her information is going to be slightly different. So polymorphic pattern states that because Serena plays tennis, and because tennis has a couple different types of events, Serena's document can look like this. We'll have all of her typical information, but we can also store the events that she's a part of. In this case, tennis can have both singles and doubles events. We have changed her particular document to hold her events in an array in this way. And polymorphic is kind of the basis for most of the design patterns, and that just says that her document looking like this can exist in the same collection as Kobe Bryant's, who may not have those types of event information in his document. So attribute pattern. The next pattern here is very, very useful for problems that have a lot of documents with a lot of similar fields, but the ones that you're actually querying is just a small subset of those. So in this case, let's say we are keeping track of all the different movies. And in our application, we want to search for them by the release date. The problem with that is release dates are different across all countries. It's not a single release date. And so in our very, very naive data model, we found that we have placed a top-level release date field for every single one. The problem with this is that if we store it in this way, we need to have indexes for every single one of those release date fields. So in this case, something like the attribute pattern is actually very, very helpful because instead we can change the document to look like this. So instead of having every release and every location be a top level field, we have an array that we will be indexing. And because we know we're going to be searching by the release date, we'll have the attribute be the date and the actual location because we know it's different for every location. So by having it in this way and storing that particular attribute, the attribute that we want to search on, our index can be much, much simpler. We'll only have to do it on this array here. That is possible, including the subfields as part of that array. And the great thing here is that the queries are also way simpler because now you don't have to add every single index that you may possibly need for all of the top level release date fields. Finally, there is the document versioning pattern. So this is really good pattern to use when you're faced with maintaining a lot of previous versions of documents, but you still need access to the most current version of your document for your application. So one really, really boring example, but I tried to make it as fun as I can, is insurance. So insurance, when you start out with insurance, you open up and get a policy, you have a standard policy writer, right? And when you start out, you maybe have only a few things that you need to insure. So Bilbo here has decided to get some insurance. And at the time that he opened this up, the only things he needed to insure were the elven sword. Now, with the document versioning pattern, this makes sense, right? This would be a collection of current policies. So every person that has insurance with us would have a document in the current policy collection, and that would be the most current, the most up-to-date status or state of that insurance. However, as Bilbo goes on and travels on and, changes a few things, let's say now he has a one ring to insure that's very, very important. Well, we can use the document versioning pattern to now add that one ring to our current policy. And to keep track of the old state of insurance, we would have a different collection, maybe one called policy revisions, and we would add a document there that would hold the old state or revision 1 of his insurance. So in this way, we now have the most current state of his insurance. We would always be querying and targeting the current policies collection for that information. And then we would keep the history by adding the different revisions that do occur in a separate collection. So of course, the cons of this is that it doubles the number of writes because we now have to add a new document every time a revision is made. But keeping that in mind, we kind of apply this to not only where you need to keep track of revisions, but where revisions are not so common. So that's why insurance is kind of a good policy. You don't change it that often unless you're a very volatile lifestyle and need to change your insurance very often. But yeah, and then one of the biggest pros of this is that it's very, very easy to implement even in existing systems because the way you implement it is simply by adding a top-level field, an identifier. In this case, we simply used an increasing integer here. You can use a different type of way to determine which one is the most current state, but as long as you target the right collection and you target the right revision, then that's the way you can apply the document versioning pattern. One thing that I did not add in here that is also very, very common is something called the schema versioning pattern. So in a very, very similar fashion, you would have two types of schemas. So let's say you have a very, very different schema and you're in the middle of a migration or you added a feature and you wanted to test something out. The greatest thing about this is using this same kind of pattern where you denote which schema version you're using. You can have both types of schemas exist in the same collection. And that's something that a lot of people do when they migrate to something else. So instead of having full downtime and doing a full migration over to the new schema, even if it's just a single field that you are adding or removing, you can have both of those documents exist in the same place, and you can have them exist for a while. Now, obviously, you have to adapt your application to that. You have to make sure you are targeting the right schema version in your application, and you have to make sure that you remove the older documents or the documents with the schema version you no longer need so that you clean up your collection and also reduce the data size. But that is one very, very common way to be able to have two different versions of your documents exist. Yes? Say again. In the current collection, this is so if you needed to target specifically that particular person and that most current one, then that's the easiest way to find it. You can also add an index via the revision number. And if you have duplication across both the collections, it's an easier way to target it via that index. So you could have it, in your question, it is also still logical to only have the revision number in the policy revision document, but just for being thorough, we add it to the existing one. That way, when we do duplicate and add that particular document to the policy revisions collection, we already have that particular revision. So you're correct. In the current policy one, you don't have to have it. You could still target it because, again, building that assumption that the current policy collection is always the current, then yes, you can build that assumption in that any document in that collection will be the most current. But in case that doesn't happen, something changes, at least you know that you have that particular field that you could query on to make sure that it is the most current one. And we actually have way more patterns here, right? So we do not have time for them. So I'm actually thinking of possibly just going into a talk of just the design patterns. But the ones that we did go through were the polymorphic, which are really good for catalog and content management use cases or single view and mobile applications. We have the attribute pattern, which are fairly same use cases where we use them mostly. And then the document versioning pattern, which is also very, very good for personalization. And then the last one here, schema versioning, as you can see, which is pretty good for any use case. All right, so you've learned the methodology. You now know if you were to leave everything shut down and that's the end of this presentation, you now know how to actually do it. But I find that going through an example somewhat solidifies that understanding. So we'll go through it now, and we'll go through it for a casino floor analytics application. So the first step in this phase is to make sense of our workload. Who here has been to a casino or Las Vegas? Okay, that's good. It's a dizzying place, right? It looks like this. It is purposely built so you have no idea what time it is, you don't know where you are, you don't know what's happening, it's dark, it's a little not so much smoky anymore because they've outlawed that, but this is kind of what it looks like. And so for our particular application, we're going to build one that looks into the slot machines in particular. We want to keep track of all of these things. I think I've pointed them out, yeah. So there's all kinds of different slot machines, right? There's one for your favorite TV show, one for your favorite movie, like there's a slot machine for everything. And in our application, we want to keep track of certain analytics of our slot machines. So that can be the win chance rates, the jackpots that are associated with it, the bonus structures depending on what type of slot machine it is. And so we'll go through a quick example of how we would possibly develop a data model for that kind of application. So when we make sense of our workload, we find that these are the most important queries that we want to focus on. So first one, total player game time. So if you have a membership card at most of these casinos, when you put that membership card into the slot machine, we can tap into that right. We know when you put the card in, we know when you take the card out, and that's a somewhat accurate estimate of how long you spent at that particular slot machine. So that is one of the most important rights that we can have as part of our application. We have a few more reads that we can use as part of our analytics. So that's the win chance rate, the anomalies in the win rates, and the top slot machines played. So for the win chance rate, there's not much that we can do there. There's a Nevada Gaming Commission that kind of sets what those ranges can be. And you have very, very slight creativity where you can move those ranges, but it's kind of set by that board. But we have that information, and that is a read that we can see what the current range is right now. Anomalies and win rates. So there's analytics on table games, but there's also analytics on slot machines. So if you've ever seen Ocean's 11 or any type of casino movie, any heist type of movie, there are a crap ton of cameras there that help out with this. They measure your temperature, they measure the way that you walk, they measure what you're looking at the moment, they measure how quickly you get excited, and they have all types of ways to tell if that win is genuine or if it's not, if you're cheating. And so we have a lot of access to that information because most casinos have a very, very rigorous fraud detection system. And then the top slot machines played. So we have some analysis on the slot machine playtime from that player card mechanism that we have, but we also have replay conversions. So in a similar fashion, You know, some people have their favorite slot machine, or they're like, this is a hot one, I'm gonna win it. It's hot, I feel it. And they come back to that and they keep pouring money into that. We can not only tell how long they've played in that particular slot machine, but we know how many times they've come back based again on how many times they've put in their membership card. So we know the top slot machines that have been played because we can aggregate which ones have the most playtime and which ones have the most replay conversions. And then finally, one of the last important rights that we have are jackpot increases. So if you've ever seen these slot machines where it's like a network of slot machines, maybe they're in a round or a ring, sometimes they span across multiple casinos, they're all connected to a single screen, and it's a jackpot that continuously increases. And as people play, the more that people don't win, the more the jackpot increases. And so those increases are something that we can tap into, especially if they span across multiple casinos. As the jackpot increases, or when somebody wins that final jackpot, we reset that jackpot and the new jackpot starts. But what we are tapping into is the continuous rights of how many times the jackpot increases. So we've made sense of our workload. This is the more simplified version, and we'll get to why that is in a moment in our third section. But those are the most important queries that we find. Those are the ones that we need for our application. So we take that information, and now we need to map out which pieces or which entities are the most important and what types of relationships exist between all of those things. So we find that as part of the information that we have, a lot of our information actually falls within a one-to-many type of relationship. The only one that is kind of different right here are the slots and casinos, because slots can only ever physically be in a single spot, in a single location, in a single casino. So that's the only one-to-one relationship that we find. Everything else, from slots and the different type of bonuses that we have, to the casinos or the jackpots, and the slots and the players and the memberships, these are the most important relationships and the most important entities that we have. And now we apply the design patterns. So in this particular application, this is what our data model could look like. So for our slots, our document will look like this. We want to keep track of the type, the manufacturer, the location that it's in. We want its serial number, bonuses, etc., and also a revision. Our jackpots would look like this. We would hold the current total of the jackpots as well as the participating slots. We have casinos that we have determined to be a good place to hold the casino information, which we also added the top slots, the floor manager, etc. And we also have the players, which has their membership information, are they a high roller, and their contact information, etc. So this is our starting data model, or actually the ending data model that we have. And we found that these are the pieces or entities that we found would make great collections, great top-level collections to hold our data. So the first choice we've made in our data model is denoted here. So everything you see here that's circled or bordered in white are the things we've decided to embed. So for slots, every time that we query for information on slots, we usually need the bonus structure that is associated with them. So we may store bonus information in a different collection, but we've also opted to embed them in the parent slot documents because of the way that we query them. In a similar fashion, we also have the participating slots in the jackpot documents. We have the top slots for the casinos that are embedded. And we have embedded both the membership information as well as the contact information for our players. So all of these decisions, all of these embedded pieces of information are purely because we need that information whenever we query it. Okay, I thought it was my phone. So that's option number one, and that's decision number one in our data model. We've embedded those pieces. The next thing that we've decided to apply is the document versioning pattern. So we have in our slot documents very similarly to how we did the insurance example, right? We do have another revision identifier here because slots go through a lot of different changes. Some of them are being decommissioned, some of them are getting maintenance on them, so some of them have the bonus structure or the win chance rate changing slightly, so we want to keep track of these particular pieces of information for our slot machines. In the same way, players also change all the time. Maybe they had one really, really bad weekend in Las Vegas and they're no longer a high roller. We want to keep track of that revision. Sometimes they're not a member anymore at one casino or the other. We want to keep track of that. And then in a similar fashion, contact information changes, not too much, but sometimes it does. They get a new cell phone, they move, so we want to keep track of that information as well for our players. Next is the attribute pattern. So this applies particularly to the slots, and in this particular case, it is because of the bonuses. So if you've ever seen the different types of slot machines, there are slot machines that have different games on it, and that will feed into our next pattern here, which is the polymorphic pattern. So putting those two together, the attribute pattern of the bonuses and polymorphic, that shows. So we have polymorphic here that's about to be shown. So attribute pattern right here is we are querying mostly on the bonuses. We want to know which bonuses are doing the best, which ones are attracting more people to those particular slot machines. And with the polymorphic pattern combined, we may have different types of slot documents that exist within the slot collection. So a typical slot document would look like this. This one could be for the one that I was just talking about. So in this case, we have some game bonuses that hold the type of game, the bonus type, bonus percentage. So some slot machines have, you may see these, you can choose the game that you want to play. There's Texas Hold'em, there's Jacks or Better, there's Blackjack, there's all kinds of different permutations of card games that you can choose. And depending on which one you choose and depending what level you are you in the penny slots, are you in the dollar slots and making a lot of money, you can choose the game there and then those particular bonuses will also change with that. And then a document can also look like this. So as I was mentioning, there are probably, I would bet, half of my salary to say that there are no more mechanical slot machines left in Las Vegas. So if you've ever been there before, you've seen the wheels. Those are all actual mechanical parts that actually spin, and those are very, very costly to maintain. Sometimes they break, sometimes they cause people to win, and the casino doesn't like that because of a flaw or something. And so if you ever go back now and you take a look at those slot machines, those are all actually digital wheels. They look very, very realistic, but they are no longer mechanical. And so for those types of slot machines, their document could look like this. So their information would hold not just the decommission date, let's say they've taken that old one out, put a new one in, goes into the slot machine graveyard, but while it was in service, we have a maintenance log for the different types of services that it obtained as well as when that occurred. So again, polymorphic just states that for all of these different kinds of slot machines and more, all of those different type of documents with different types of fields and different types of information according to the slot machine that we're keeping track of can exist in harmony in the same collection. And that's it. That's our data model. So let's take a look at it very quickly. We've applied the document versioning pattern with both the players and with the slot machines. We have polymorphic pattern applied particularly to the slots because of all the different types of slots there are. And we have the attribute pattern applied in particular to the bonus structures for the slots. And you'll find that all of those additional sub-documents from the top slots to the contact information, the membership information, the participating slots, as well as the bonuses here, those have all been opted to be embedded because of the way that we query them. And this is what our data model could look like. Now, this is what it could look like at this moment, but let's say our application changes. There's some new fancy, I think there's a new slot machine now, which they're trying to target to millennials, where you actually play video games and that's how you play. I don't know how that's going to work. I don't know what those bonus structures look like. There's some of them where you play Tetris. There's some of them where you play Space Invaders. Like they're trying to really get millennial money, the money that we don't have, and give it to the casino, but they're trying to find another audience, and they're building those types of slot machines. So when those pieces of information change, or there's different types of attributes for those types of slot machines, we can go through this process again, and maybe we find those slot machines are the ones that are doing the best, and we change our data model accordingly. So that's the best part about doing this type of work and developing this type of data model, is that as your application evolves, as the pieces of information that you work with changes, as your workload changes, you go through these phases again and see if they need to be done in order to give you a better data model. It's an iterative process that goes along with the application development process that you may go through. And those are the three phases, right? Make sense of your workload, gather everything there is to know about your data, move into the phase 2, which is to map out what relationships are there and decide whether to link or to embed them, and then only if necessary, apply design patterns. So the last question, what do we actually model for? And in most cases, it's actually important to choose this early on, but you can also do this the second time around. And when it comes to choosing a data model for document databases, these are the two options. Is it simplicity or is it performance? And there are a few things that we need to take a look at. So for your data model, if you are on the side of simplicity, which is what we usually encourage, you'll want to take a look at the size of your project. Is it a small one? Is it an early stage app? Is it an MVP? Is it something that only you will be using or your team will be using? What is the size of your team? Are you going to be the sole person that's handling this application as well as being the DBA for it? Do you have a smaller team where you may not have as much dedicated time to put into this? What are the data sizes that you are dealing with for your application? Are you using shared resources? Do you not have that much traffic? What is your expected scale? Do you have very, very few users, or do you only have traffic that's maybe like, a few hundred requests per hour? Some of the applications that I've worked on in the past had that type of scale, yet some of the engineers that we had wanted to prematurely optimize for thousands of requests per second. I said, whoa, we don't need that right now. We only have this much based on our production logs. At the most, we're only ever going to get maybe like 500 or 600 requests per 2 or 3 hours. So when you have those types of pieces of information from your first phase, it's a good way for you to justify, no, we need to actually add some more changes because we need more performance because we have this type of expected traffic. Or you can say, no, we don't need all of that complexity right now. This is what we're dealing with. Let's choose the simpler data model. And of course, it falls on the other side of the spectrum if you do need to model for performance. So if your project is much larger, if you are a distributed project, if you have a very, very large team or distributed teams, you have more people to be able to focus on these issues and focus on continuously iterating that data model. If you have sizes that are very, very large, so you are already sharding your clusters and you are on multiple regions, and if your expected scale is at that rate, you're dealing with thousands of requests per second, or you're a very write-heavy application, then you can start to consider, yes, performance is probably something we should be modeling for. As always, err on the side of simplicity. So because this is an iterative process, because we can do this over and over again, you always want to start out with the most simple data model, because that's always the easiest one to build on top of. It's always the easiest one for you to understand 3 months later when you look at it, and it's always the suggested route to go through. Start simply, build upon it only if you need it. To do that, you would focus on the most frequent operations. So again, those phases are very important because when you decide what you're going to model for, simplicity or performance, you can pick those pieces out. So maybe you have listed out the top 10 or 20 operations that you have. For simplicity, focus on the most frequent ones. Focus on the most important ones, the ones that your application can't live without. Embed most things, and then again, only use a pattern if it makes sense. For the most part, the pattern that you would probably most likely benefit from are either the document versioning pattern or the schema versioning pattern, and that's probably it. That's good enough for you. If you want to model for performance, This is where it gets a little bit more tricky. There's a little bit more work involved. You need to consider all of those operations. You want to make sure you have that granular detail. How many writes per second? How many reads per second? What does your traffic look like? At what time? What causes traffic spikes, etc., etc. You want to embed and link as necessary. So when it comes to performance, you most likely won't be able to get away with just embedding everything, especially if you're dealing with a large number of documents. Linking will be necessary because embedding too much information is also a bad thing. And then, of course, you want to use as many patterns as necessary and as needed. So maybe you're not using all of them right away, but you build upon it as you find that you need it. So what most people do is they go somewhere in the middle, right? Actually, they want both because everybody wants everything. They want their cake and eat it too. So you fall right in the middle. And so in this case, you go most operations, maybe the top 5, maybe the top 3, you will want to embed and link, and then you'll only want to use a few patterns, but then continuously add more patterns if you find that your current application doesn't meet some sort of performance threshold that you have set for yourself. And with that, I want to say salamat. That means thank you in Tagalog. I hope you learned something about data modeling, maybe more about slot machines, but I'm very happy to answer any questions that I can answer. Thank you so much. Yeah, thank you. Yes. If I understand your question correctly, can the application determine which version of the document to use? Okay, sure. Yes, so depending on the document database that you use, my background is in ex-MongoDB, but MongoDB and I'm sure DocumentDB and CosmosDB have something similar. You can use either a trigger or you can use some write rules to enforce that schema. So there is schema validation that is applicable to your collections. So in that case, let's say Floor Manager, you want to make sure that it always has it. I mean, it will exist. If you manually overwrite it, if you insert a document without one, it's going to be possible. But if you want to make sure from the application that it goes through that schema validation, there are rules that you can apply that says even though it can exist, you don't want it to. So there are rules you can apply with schema validation. Yes. So one way that this has been implemented is to do it based on the microservice itself. So whatever the microservice needs, whatever information that particular piece needs, that's what you would, I guess, use to guide which parts you embed. And so it won't be as straightforwardly cut as this. This isn't a typical application, right? Either a monolithic application or something that's not so distributed, but that goalpost would move to, instead of that particular entity or what you query for, you now embed the things that would be needed by that particular service. Repeat one more time. Okay. If I understand your question correctly, there would be the application of both the document versioning pattern. So you could have both pieces or both versions of that exist, and then it would be up to your application to query the correct collection. For the shared objects, there is an option to do something called a union all or an out, where let's say the pieces that are shared, they change very often. If you're changing the base collections, so let's say there's shared pieces of information from two collections and that merged together is what's shared across certain different pieces, what you can do is use an aggregation pipeline to kind of collect that information and then send it outward. So you can replicate or you can update those models and update the collection as necessary. But one way to do it is to get the aggregation pipeline, use some sort of identifier to get the version that you need, and then aggregate that information to be sent off to what is being shared. I don't know if that answers your question. I answered it in the way that I think. Oh, okay. In that case, to know where, so with the duplication of information, if you do embed it, there are database triggers that you can use. So let's say you are updating the parent document, right? You are updating the casino info or the owner information that we had, which we had embedded. If we are updating that particular owner document, there can be a trigger that looks for anywhere that it has been embedded. In this case, you would have to use some sort of identifier to know where it has been embedded, and then it can do a cascading trigger to all of the documents to update accordingly every time that parent document has been updated. So in that way, that's one way to do it, to kind of keep track of all the places you may have embedded and make sure it does update accordingly when you change it. Yes. Mhm. Yes. So the guideline there is if most of your documents or even some of your documents have to be switched over into a linking manner, it's best to actually change all the documents to fall in that format. That way you don't have two different versions of that. So you don't want to reach that. That's an excellent point. Most documents, MongoDB, for example, has a 16 megabyte limit per document. So if you start reaching that limit or you're even getting anywhere close to that, that's also another guideline to say maybe you shouldn't be embedding. This is already pretty large. You want to probably break it up and start linking those pieces of information. So yeah, that is a good guideline to just say if you're reaching that limit, or if you find that you have a few that you even need to change, it's better to have, even though it's possible to have both versions exist, when working with it in an application, it's much easier for you to deal with if you just change everything to the linking format for that document. Any other questions? If you think of one, I'll be around for a moment. You can come up here as well. All right, thank you so much.